Today we're going to talk about writing equations for tangent and normal lines. So to start off, I want to recall the point-slope form of a line equation. You might have learned this in geometry, and we reviewed this at the beginning of the year. Point-slope form looks like this. Y minus y1 is equal to m, which is the slope, times x minus x sub 1. That's useful when you're given the slope and a point. So slope m and a point x1, y1. It's a one-step process. You just take your values and you substitute it in. So let's say I have a slope of 2 and I have a point of 3, negative 2. Well, here's x1 and here's y1. You just substitute in your values to get your line equation. Y minus a negative 2 is equal to 2 times x minus 3. And that's how we'll leave the answer. We don't have to distribute or add the opposite to get y by itself. And this is what you will do in calculus next year. We're going to leave it right like that. So the next thing I want you to recall is the fact that perpendicular lines have slopes that are negative reciprocals. So you take the slope and you flip it, and if it started out as positive, you make it negative, or if you started out as negative, you make it positive. So if I start off with a slope of positive 2, then the perpendicular slope is negative 1/2. So taking that original line equation, y plus 2 is equal to 2 times x minus 3. If I wanted to write the slope of the line equation of the line that's perpendicular to that one at the same point, which was 3, negative 2, all I have to do is change the slope and everything else stays the same. So the perpendicular line would be y plus 2 is equal to negative 1/2 times x minus 3. So that's some of the work we're going to be doing today after we find the slope of the tangent line. Just a little bit of terminology. Perpendicular is also called normal. And that's the regular word that we use in calculus. So we're going to be finding the slope of the tangent and the normal line to the line that's perpendicular to the tangent line. So from yesterday, we developed a formula for finding the slope of the line tangent to a point on a curve. And just as a quick refresher, if I have point A, my x value is c, and point B, my x value is c plus h, because h is the difference, is the space between the first x value and the second x value. And what that does is create two coordinate points. The first one is c and f of c, and the second one is c plus h and f of c plus h. From there, what I wanted to do was move point B all the way over here until it coincides with A, and that gives me a tangent line. So I want to find the slope of the tangent line. In order to do that, I can't just use the slope formula. So to start out, I have f of c plus h minus f of c all over h. But that's not going to work because I really want to evaluate this function when h is 0. So I have to take the limit as h approaches 0 of all of that. And that gives us the slope of the line. It gives us the slope of the tangent line. If we have the slope of the tangent line, we can easily get the slope of the normal line at the same point because you just take the negative reciprocal. So we're going to be writing line equations today, and we're going to be using what we learned yesterday to find the slope of the tangent, because if we have the slope, we can write the equation of the tangent line at that point. So the trickiest part about this is finding the slope. We're going to walk through an example. Given f of x is 2x squared, the first thing I want to do is find the slope of the tangent line when x is 1. So that's the process we learned yesterday. We have to find f of c, or f of 1 in this case. F of 1 is going to be 2 times 1 squared. So f of 1 is 2. I have a coordinate, 1, 2. That's the point where I want to find the tangent and eventually the normal line. So I have to find f of 1 plus h. F of 1 plus h is going to be 2 times the quantity 1 plus h squared. This is where most of the work is going to be, because I have to expand the 1 plus h. I would multiply this out and then combine terms. So I get 2 times 1 plus h times 1 plus h, and I'm going to move that up here. I get 2 times 1 plus 2h plus h squared, and then finally distributing the 2, I get 2 plus 4h plus 2h squared. That's what I get when I multiply out f of 1 plus h. So I have all these values. I have my original function, f of x is 2x squared. I know that f of 1 has a value of 2, and f of 1 plus h, when it's multiplied and simplified, it's 2 plus 4h plus 2h squared. Now to find the slope, I'm going to evaluate the limit. It's the limit as h approaches 0 of f of 1 plus h. So that's 2 plus 4h plus 2h squared minus f of 1, which is 2, minus 2. And you'll see the constant terms subtract away, and I can reduce my h down. The limit as h approaches 0 of 4h plus 2h squared all over h. This allows me to reduce my h down, and I'm left with, I'm going to come over here, the limit as h approaches 0 of 4 plus 2h. So the slope of the tangent line, when I evaluate that function, when h is 0, this part of it goes to 0, and I'm left with a value of 4. So the slope is 4. That's the slope of the tangent line when x is equal to 1. So now I want to write the equation of the tangent line at x is equal to 1. Well, all the hard work has been done already, so let's write down what we know. When x is 1, f of 1 is 2. So here's my point, 1, 2. I just found the slope of the tangent line. We said that was 4. So I have x1 and y1, and I have my slope. To write the equation, it's just a matter of substituting in. Y minus 2 is equal to 4 times x minus 1. And that's it. That's the slope of the line that's tangent to the function when x is 1. Finally, I want to write the equation of the normal line at x is equal to 1. To do that, we start with the tangent line that we just found. The line that's tangent is going to be y minus 2, and that's equal to 4 times x minus 1. It takes one step to do this. All I do is I take my slope and I write the negative reciprocal, and that's going to make the perpendicular line, or the line normal to this line, at the same point. So just rewriting my perpendicular or my normal line. Again, it just takes one change. Y minus 2 is equal to negative 1/4 times x minus 1. So that's what we're going to be doing in class, only some more complicated functions as opposed to this one. The steps basically are find the tangent slope, and then you use y minus y1 is equal to m times x minus x1 for the line equation. And then for the normal equation, it's going to be y minus y1 is equal to negative 1 over m, the negative reciprocal of x minus x1 for the normal equation. So we will be practicing all of that in class and looking at some graphs and some results of our examples.